Hello and welcome to another video with me, Alex. This time we're going to be looking at coordinate geometry again, and we're going to be looking at parametric equations. Okay, this is going to tie into the Edexcel module C4, and this is chapter 2. Okay, so, well, first of all, what are parametric equations? The first thing that I'm going to say is, what is a Cartesian equation? Now, a Cartesian equation is something that you are very familiar with, even if sometimes you forget what it's called. So let's look at an example to look at the difference between Cartesian equations and parametric equations. Right now, I'm just going to do a quick sketch of a graph. Okay, this is x against y. This graph is in fact the graph of y equaling x squared. Okay, this is the Cartesian form of this graph. Okay, this is our Cartesian equation. It directly relates x to y. A parametric equation is when we have separate equations for x and y, and they are in terms of some other variable, let's say t. So instead of y equaling x squared, we'd have x equaling some function of t and y equaling some other function of t. Now, in the case of y equaling x squared, x would equal t and y would equal t squared. This is our parametric equations. Okay, so Cartesian equations directly relates one of the variables to another variable. Parametric equations, they describe the variable based on some third variable. In this case, I've used t, but you could use whatever letter you want. Okay, so that's parametric equations. What do we need to be able to do with them? Well, the first thing that we need to be able to do is we need to be able to plot graphs using the parametric form. Okay, so again, let's take the example that we've just looked at. Let's look at x equaling t, y equaling t squared. So what we're going to need to do is we're going to need to look at t, x, and y. And we can literally plot this graph by just calculating all the values in this table. So you may be asked to plot parametrically these equations from -3 to 3, let's say. And all you have to do is, well, t is equal to -3, that means that's -3, and that would be 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, and 9. And then we could literally just plot these. So -3, 9 is going to be up here somewhere. We're now plotting y against x. Okay, we're plotting directly x against y, y against x. So -3, 9, that's up here somewhere. -2, 4, that's like maybe here. 1, 1, that's like here somewhere. -1, 1, sorry, 0, 0 is obviously there. This would be somewhere around here. 2 4s up here. 3 9s up here. And then we can join them up. And as expected, we end up with a simple quadratic. We have the simple quadratic there, and that is how you would plot equations parametrically. It's as simple as that. So that's the first thing we need to be able to do, and it's fairly simple. The next thing that we need to be able to do is solve basic geometric problems using parametric equations, and I'm going to show you this through a really simple example. Okay, the type of questions, so you need to be able to solve geometric problems. Okay, and what do I mean by that? I mean stuff you've been doing for years in Cartesian, for example. Find where y equals x squared minus 4x plus 2 crosses x-axis. Okay, that kind of question, but we're now going to be in parametric. Okay, so let's look at an example, and we'll use that to just show you the sort of thing that we might have to do. So we're going to do this exact example, but with different equations. So we're going to find where x equals 1 minus t, y equals t squared minus 4 crosses x-axis. Okay, so how are we going to do that? Well, we know that it crosses x-axis when y equals 0. So we can say that 0 is equal to t squared minus 4. T squared would be equal to 4. So t would be equal to plus or minus 2. Okay, then all we have to do, is sub in t equals plus minus 2 into x. We have that t equals 2, x would equal 1 minus 2, which would be minus 1. T equals minus 2, x would be equal to 1 minus minus 2, which would be 3. So our coordinate axes would be equal to minus 1, 0, and 3, 0. Simple as that. Okay, so nice and straightforward. Hopefully not too complicated. That's the sort of problem that you might be asked to solve. That in more complex situations, but it's nothing to worry about. All you're doing is applying the knowledge you already know. You know that when a graph crosses the x-axis, y is equal to 0. You use that knowledge and you apply it in this slightly different situation, and you can solve these parametric problems. Okay, so that's that. Next thing that we need to be able to do is that we all need to be able to convert from parametric to Cartesian. Okay, so let's look at the example that we've just done. Let's find Cartesian form of x equals 1 minus t, y equals t squared minus 4. Okay, that's going to be our question. The way we go about it is if we rearrange this equation for x, and we can say that t would be equal to 1 minus x. Okay, and if we sub that into y, we'd get that y equals t squared minus 4 still, which would now be equal to 1 minus x squared minus 4, which if we expand the brackets would be 1 minus 2x add x squared minus 4. So we'd be able to say that y would equal x squared minus 2x minus 3. Perfect. That's then the Cartesian form of this parametric equations. Okay, I'm going to show you another example of this because it's an example that comes up all the time, and it's a little trick that you will use all the time. So I'm going to show it to you. We're going to find Cartesian form of x equals sine t plus 4, y equals cos t plus 2. Okay, I'll give you just a moment just to think about how you might go about finding the Cartesian form for these equations. Okay, hopefully some of you have maybe come up with an idea. I'm going to show you how you do it. We're going to rewrite both of these equations. So if we take the one involving x first, we're going to rewrite this as sine t equaling x minus 4. I'm going to label that 1. Okay, so all I've done is move the 4 to the other side. I'm going to do the same for the y, so I'm going to get the cos t equals y minus 2. I'm going to label that 2. Now what I'm going to do is if I square them both and add them together, I get that sine squared t add cos squared t would be equal to x minus 4 squared add y minus 2 squared. But we have an identity that says if you have sine squared plus cos squared of the same argument, that's just equal to 1. So you end up with x minus 4 squared add y minus 2 squared, and that's equal to 1. So this would be a circle, center 4, 2, radius 1. So there you go. That's a little trick that actually you use all the time in math. You use it all the time in math. You use it all the time in physics, where you can add together two sine, a sine squared and a cos squared, and they can cancel and they go down to 1. It's a really, really useful trick. Okay, so that's a big part of this chapter, is actually changing between Cartesian and parametric equations. And then we've got one last bit that's actually not too difficult. It might look a little bit daunting at first, but once you start doing questions, you'll see it's not too hard. And it's finding the area under a curve parametrically. So we've been using for a while now the fact that the area is equal to the integral between a and b of y dx. Okay, but if we've been given our equations parametrically, well, y is not in terms of x, so we can't really integrate it in terms of x. It's not going to work. In fact, we have that y is some function of t and x is some function of t. Okay, but what we can actually say is from this x, we could say that dx by dt is equal to f prime of t. Yeah, makes sense. And we can rearrange that to say that dx would be equal to f prime of t dt, or written slightly differently, which I think we can conceptually understand, dx would be equal to dx by dt dt. That's the chain rule. Okay, so that means that we can now rewrite the area, and we can say that the area is equal to, still between a and b, but now a and b need to be calculated to be values of t. So whereas before it would have been values of x, now it's values of t between 2 points, and it's equal to y times dx by dt dt. So if you get given two parametric equations, all you need to do is you need to calculate dx by dt, you multiply it by y, and you integrate with respect to t, and that will give you the area. That is the whole chapter. That's all that we've got to look at for this chapter. It's now your job to go away and apply the content, do lots of practice questions. If you need any help or any clarification on anything, drop me a comment, and I'm sure we can work something out. Thanks very much for watching, and tune in next time.